Good morning, guys. So today we will discuss rational function. So first of all, we will discuss reciprocal function f(x) equal to 1 over x. So let me define the rational function. Okay, so if you have a function f(x), equal to px over qx, right? Where px and qx are polynomials with qx is not equal to 0. Okay, so this is a rational function. This px and qx, and they are polynomials. Okay, so this is the definition of the rational function. You got it? If you have a function f(x) equal to px over qx, where qx is not equal to 0, and px and qx are polynomials, so this is called a rational. This is called rational function. Okay? So now, if you want to find out examples, so let's say f(x) equal to x plus 3 over x minus 2, or gx equals to 1 over x, right? Or rx equals to 1 over x squared. So they are examples of rational function. Okay? So these are the examples. So the rational function, they often hide discontinuous graph. So that means the graph has one or more breaks in it. And this is the reciprocal function. This is the very basic, the simplest rational function. f(x) equal to 1 over x. Okay? So now if you want to draw the graph for f(x) equal to 1 over x, so we want to graph f(x) equals to 1 over x. So what is the domain of this function, guys? How do you find the domain? What will be the domain of this function? So for what values of x, this function will be well defined, right? So, or let me ask you one question. For what value of x, this function is undefined? 0. So now we have to exclude 0 from the number line, right? So now if you exclude 0, so that means you see the domain is going to be negative infinity comma 0 union 0 comma positive infinity. So the domain of this function is negative infinity comma 0 union 0 comma positive infinity. Okay? Did you see that? This function is defined for every value of x except 0, right? Other than 0. So let's make a table, okay? So you have a x value here, you have a y value here. So you know the y is same as what fx. So you guys know if I plug in 0, here, this function is what? Undefined, right? If I plug in x equal to 0, so this is undefined. Make sense? Now if I plug in negative 1, what will be this? So if I plug in x equal to negative 1, so exactly negative 1. If I plug in x equal to negative 10, what will be this? Yes, negative 1 over 10, right? So this is negative, what is the decimal number for? Yes, 0.1. If I have a negative 100, what will be here?
Would be the negative 1 over 100, or
Yes, negative 1 over 100. The decimal for this one is negative 0.01. Make sense? Did you get it? So now, so similarly, if I plug in negative 1000, and you guys know that it's going to be negative 0.001, is that right? Right? And then if I plug in positive 1, it would be 1, right? So if I plug 10, it will be positive 0.1. If I plug in 100, right, for x, so it will be 0.01. You see that? So now we observed as the value of x approaches to very, very big negative number, the y value goes to 0. Is that right? And same thing here, as the value of x is very, very big positive number, y value also approaches to what? 0. You see that? Now, if I pick, so let's say, if I pick, you have a 0, this is undefined, is that right? 0 is undefined. So if I pick x equal to, let's say, negative 1 over 10, negative 1 over 10, so what will be the value of y? If I plug in x equal to negative 1 over 10, it will be negative 10. Agree? Right? Because you plug in f of negative 1 over 10, so it will be 1 over negative 1 over 10. So you see this is same as 1 divided by negative 1 over 10. So this is 1 multiplied by 10 over negative 1. What is that is? Negative 10. Right? So if I plug in, let's say, negative 1 over 100, what will be this? If I plug in x equals to negative 1 over 100, what will be this? Negative 100. See that? If I plug in negative 1 over 1000, so it will be negative 1000. Is that right? So if I plug in positive 1 over 10, if I plug in x equal to positive 1 over 10, so this will be what? 10. If I plug in positive 1 over 100, it will be 100, right? If I plug in positive 1 over 1000, it will be what? 1000. Did you see that? So now, what did you observe here? As the value of x approaches to 0 from left, because you see this negative 1 over 10 means negative 0.1, negative 1 over 100 is negative 0.01. So this is what? Negative 0.001, is that right? So as you approach to 0 from the left, your y value approaches to what? Y value increases, and it approaches to what? Negative infinity. Or it approaches to very, very big negative number. But as the value of x approaches to 0 from the right, your y value approaches to very, very big positive number. That makes sense? So what you need to know is, if you want to draw the graph, so this is your x-axis, and this is your y-axis. Now look here, if you have a 1, this is 1, okay? 1 is 1, okay? So 0 is undefined, that's okay. And then if you have a negative 10, it is 0.1. If it is negative 1, this is negative. First, let me take care of this part, okay? So this is your 0. For 1, it is 1, right? So for 1 over 1000, so this is exactly 0.001, is that right? So for 0.001, which is pretty close to 0, it is what? For 0.001, it is 1000. So it blow up here, you know what I mean? It's 1000, right? Somewhere here. Goes up. So if you have a 1 over 10, which is 0.1, it is 10. So if you have a 1 over 10, maybe somewhere here, it is what? 10, right here. And if it is 1 over 100, it is what? 100, something like that. So you see, but as the value of x is 10, it is 0.1. So if the value of x is 10, it is pretty close to the what? 0. So that means pretty close to what? X-axis, right? And if it is, even if it is 100, somewhere here, it's pretty close to 0. So now the graph looks like what? You see something like this. So you see, as the value of x gets larger and larger, right, your y value approaches to what? 0. As the value of x gets smaller and smaller, it approaches to 0. If the value of x approaches to 0 from the right, it goes to what? Positive infinity. Or you can say the value of y gets larger. It increases without bound. That makes sense? Yeah, you see, it increases like this. And now here, if you look at the negative value, okay, so you see for negative 1, let's say this is negative 1, it is also negative 1, okay, so negative 1, negative 1. But if you look here, okay, if you look here, as the value of x is negative 10, it approaches to negative 0.1. So if it is, let's say negative 10 is somewhere here, let's say your negative 10 is somewhere here, it's pretty close to 0. You see that? Negative 10, negative 0.1. So it is negative 0.1 is somewhere here. You see that? Pretty close. And now, if you look here, guys, the interesting thing is here, if the value of x is negative 0.1, it is negative 10. So negative 0.1 is somewhere here, it is negative 10. So let's say the negative 10 is somewhere here, negative 10 is somewhere here. So for this value, If x is, let's say this is negative 0.1, you see that it is negative 10. So it goes here, negative 10. And even if it is closer to 0, let's say it is negative 0.001, something like that, it blows up. You know what I mean? It goes to negative infinity. So the graph looks like what this. So this is the graph of the function f(x) equals to 1 over x. So I think like they describe here, you can see that, okay. So we also made the table. So what you need to know is, the important thing here you need to know is this, is x gets closer to 0, x gets, you see that x gets closer to 0, absolute value of f(x), right, it approaches, it increases without bound, increases without bound. So you can see, you can easily observe that in the graph as the value of x gets closer to 0. X can get closer to 0 in both directions. It can be from the left, it can be from the right also. You know that, right? It can approach to 0 this way. So when the x gets closer to 0, the value of f(x) increases without bound. You see that? Increases without bound. You see the absolute value of f(x). That makes sense? Absolute value of f(x) increases without bound. Or as the value of x approaches to 0 from the left, your y value approaches to what? Very, very big negative number. Or you can say y approaches to negative infinity. Does that make sense? As the value of x approaches to 0 from the right, this direction, you see this direction, it approaches to 0 from the right, the y value gets larger and larger. It increases without bound, or it approaches to, in this case, it approaches to positive infinity. Make sense? So, yeah. Okay. So now, the graph of the function f(x) equal to 1 over x, it never intersects y-axis, and it never intersects x-axis. You can see the graph, right? The graph never intersects x-axis and never intersects y-axis. Makes sense? You see that, right? Look here. This graph, so this graph never intersects x-axis. You see? It's pretty close, right? But it never intersects x-axis. You see? Very close, very close. It goes like this. It's very, very close, very, very close, very, very close, very, very close, but it never intersects x-axis. And the same thing here. It's very, very close, never intersects x-axis. So that means the graph is asymptotically, okay? So have you heard about this old asymptote? So that means this x-axis is the what? Horizontal. X-axis is the horizontal asymptote. Or you know the equation of x-axis is y equal to 0, is that right? Right? You know the equation of x-axis is y equal to 0. You know that. Every point on the x-axis has y value 0, right? Right? So what is the coordinate of this point? Negative 1, 0. What is the coordinate of this point? 1, 0. What is the coordinate of this point? 10, 0. So y value is 0 on the x-axis. Is that right? So that's why y equal to 0 is the equation of x-axis. So y equal to 0 is the horizontal asymptote. Are you guys with me? right? And then the same thing happens for the y-axis. The graph never intersects y-axis. So that's why y-axis is the vertical asymptote. Okay? So let me write down here. Y-axis. What is the equation of y-axis? Every point on the y-axis has x equal to, has x coordinate 0. Is that right? So x equal to 0 is the vertical asymptote. And if you look here, your function, you see what happened here. Does the function increases or decreases here? What does the function increase or decrease here? Here, look here. What happens to the function here? Does the function increase or decrease? Decrease. So the fx decreases on the interval what? So you can write decreases fx decreases on the interval -infinity, 0. And what happens here? Is this increasing or decreasing? Does the function increase or decrease here? It also decreases, right? You see the graph, right? So the function decreases on the intervals -infinity, 0 and 0, positive infinity. And the domain is, I think we already wrote down the domain. Domain is this, and the range, the range is the state of y values. So if you look at the range, right? So the function is good for every y values except 0. There is no x values for which the functional value is 0. There is no x values for which the y value is 0. Right? So that's why the range is -infinity, 0 union 0, positive infinity. You can see from the graph, there is no x values, right? The graph never intersects x-axis. Is that right? Right? Are you with me? So y cannot be 0 because the graph does not intersect x-axis. Right? Yeah. That makes sense? Okay. And obviously this function is discontinuous. At what values of x the function is discontinuous? The function is discontinuous at x equal to 0. Right? Good? Okay, we did that one. And the graph is symmetric with respect to the origin. This is an odd function. Remember, now, you know the definition of the odd function, right? Do you remember this? Odd function means f of negative x equal to what? Negative f of x for all x. So this is the definition, So now what is your function? Fx equal to 1 over x. So what is f of negative x? F of negative x is what? F of negative x, you plug in negative x for x, or you replace x by negative x. So you have 1 over negative x. So this is negative 1 over x, and negative, this 1 over x is what? Fx, right? So you see that? F of negative x is equal to what? Negative fx. So that means this function is what? Odd. And then this is symmetric with respect to origin. If you want to test symmetry, with respect to the origin. Right? So that means the replacement of x with negative x and y with negative y results to an equivalent equation. Remember that? Replacement, what does that mean? Replacement of x with negative x and y with negative y results to an equivalent equation. To an equivalent equation. So now you see that? So if you replace x by negative x and y by negative y, so your original equation is y equal to 1 over x, right? You replace x with negative x and y with negative y. So you replace y with negative y and then 1 over this x with negative x. So you have, you see this negative y equal to negative 1 over x. You multiply both sides by negative 1. You multiply both sides by negative 1. So that will give you y equal to 1 over x. And you see these two equations are equivalent. Is that right? They are equivalent, right? Equivalent. So that means this function is symmetric with respect to origin. With respect to the origin. Makes sense? So, yeah. Okay. So graph negative 2 over x give the domain and the largest open intervals of the domain which the function is increasing or decreasing. So negative 2 over x. So how do you do that? So this is the function fx equal to what? So this is the function fx equal to 1 over x, right? So if you want to graph fx equal to negative 2 over x, so if you want to graph fx equal to negative 2 over x, look here, this is your parent graph, okay, or the original graph, this. So this is, you can say this is a parent graph. Right? And then what do you need to do? So you need to either reflect reflection on the x-axis. If you reflect this graph on the x-axis, then you will get fx equal to what? Negative 1 over x. You guys know that, right? Right? Remember that? Huh? Y equal to negative fx is the reflection of y equal to fx on the x-axis. You guys know that, right? So you reflect that on the x-axis, you will get this, and then vertically stretching by a factor of 2, right? And then if you vertically stretching by a factor of 2. So if you do vertically stretching by a factor of 2, then you will get what? Fx equal to negative 2 over x. Make sense? So now, if you look at the slide, you see this graph, it should be reflected on the x-axis. If you reflect on the x-axis, you will have when you reflect this on the x-axis, what does it look like? Maybe it looks like, let me use the different marker. Look here. So if you reflect this on the x-axis, you might have something like this. That makes sense? This part will be this, and you reflect this. Did you see that? The red one is the what? Reflection of the black one, right? The black one is fx equal to 1 over x, right? So now you reflect this. Did you see that, guys? And this is the graph of fx equal to negative 1 over x. Is that right? And then you trace this graph vertically by a factor of 2. That makes sense? And you know that when the graph is vertically traced, it will be more narrower. You guys know that, right? So if you trace it vertically by a factor of 2, it will be more narrower. So maybe, like it should be more narrower. So it should be, I'm not good at it. Hold on a second, guys. Just a second, okay? So you have this. You have this, and then you have something like this. Are you guys with me? Right? So the vertical is traced by a factor of 2. So now this one is the what? Final graph. The green one is the vertical stretching of red graph by a factor of 2, right? So yep, look here. Yeah, they did the same thing, Yeah. Does that look good? And what will be the domain, guys? What will be the domain of this graph?
Would it still be negative infinity, comma 0, union 0, comma infinity?
Yes, that's right. So the domain is, you see the domain is, only the function is discontinuous for the value of x equal to 0. Is that right? They're looking at the function because this fx is negative 2 over x. If x is 0, this will be what? Undefined. So the domain is negative infinity, comma 0, union 0, comma positive infinity. Okay? And what about range? What about range? Can the value of y be 0? No, so you have to exclude 0 from the what? Range, right? Right? So the range is also what? Negative infinity, comma 0, union 0, comma positive infinity. And you see what happened here? Does the function increases or decreases? Oh, sorry. Does the function, look at the green one, okay? Does the function increases or decreases here? Increase. The function increase, right? So increases on negative infinity, comma 0, right? And what happened here? It also increases, right? Increases on this and 0, comma positive infinity. And what is the horizontal asymptote? What is the horizontal asymptote? Horizontal asymptote. You know the asymptote, right? It's like look at the graph, okay? The graph of the function, right? Pretty close to the x-axis, but never intersect x-axis. Is that right? Right?
So would it still be 0?
Yeah. So the horizontal asymptote is the x-axis. Is that right? And the equation of x-axis, you can write down x-axis, or the equation of x-axis is y equal to 0. That makes sense? And what about the vertical asymptote?
The y-axis.
Y-axis. Yep. So the vertical asymptote will be y-axis, and you guys know the equation of y-axis is x equal to 0. So I think you got it, right, guys? Okay. So now you see, if you look at the function f(x) equal to 2 over x plus 1, so you have to graph f(x) equal to 2 over x plus 1, right? And remember that, you see, the original your parent graph, or the basic function is f(x) equal to what? 1 over x. So this function, you stretch this vertically by you can stretch that by vertically stretching by a factor of 2, by a factor of 2. So if you stretch vertically by a factor of 2, then you will get the graph of what? f(x) equal to 2 over x. Is that right? And then you see, so if you shift the graph 1 unit to the left, right? So horizontal shift of 1 unit to the left, or shift the graph horizontally left 1 unit, then you will have a graph of f(x) equal to what? 2 over x plus 1. See that? Yeah. So now, look here, guys. Yeah. First, like you can shift the graph up 1 over x left 1 unit also. It's the same thing, okay? And then you can stretch it vertically by a factor of 2. You can do like this graph is shifted horizontally 1 unit to the left, right? 1 unit to the left, and then vertically stretched by a factor of 2. It's pretty much the same thing. Are you guys with me? You understand what I mean, right? So now if you do that, you'll have a graph. You'll have a graph like this, okay? So this is your x-axis and this is your y-axis. The graph of y equal to 1 over x. It look like this. Are you guys with me, guys? You see? Look like this is f(x) equal to 1 over x, right? This is f(x) equal to 1 over x. Now you vertically stretch this graph by a factor of 2, so you'll have a little bit narrower graph, like something like this. Oops. Okay? Does that make sense, guys? Yeah. Right? And then this is vertically stretching by a factor of 2, the black one. So the black one is f(x) equal to 2 over x. So the black one is f(x) equal to 2 over x, and then you shift this graph 1 unit to the left. Okay? So if you shift 1 unit to the left, so look here, every point will be shifted 1 unit to the left, okay? So what happened here is this point is shifted here 1 unit to the left. Every point, okay, this point is shifted 1 unit to the left. This point is shifted 1 unit to the left. You see what I'm talking, right? So you see every point will be shifted 1 unit to the left, okay? So now you'll have something like this. So are you guys with me? You see what I'm doing here, right? And I'm not, the scaling must, it's not to scale, okay? So just try to understand the concept, okay? You see what I'm talking, right? Every point is shifted 1 unit to the left. Hold on a second, guys. So every point is shifted 1 unit to the left. Make sense? And then this point is also shifted 1 unit to the left. So every point is shifted, 1 unit to the left. So it's see that? Yeah. So now this green one is the graph of fx equal to 2 over x plus 1. So this is the graph of fx equal to 2 over x plus 1, and it's shifted 1 unit to the left. So if this is your x negative 1, you see, this is gonna be the what? Something like this. So this is the line x equal to what? Negative 1. That makes sense? And now, so now look here, guys. The green graph never intersects the line x equal to vertical line x equal to negative 1. So x equal to negative 1 is the vertical asymptote. Make sense? So x equal to negative 1 is the vertical asymptote. Is the, let me be a vertical asymptote. And then if you look here, the graph never intersect x-axis. It's pretty close, but never intersect x-axis. So y equal to 0, which is x-axis, is the what? Horizontal asymptote. Make sense? And what happened here? What is the domain of this function, guys? What will be the domain of this function? Can you figure out domain?
Negative infinity 1, or negative infinity comma negative 1, and then union negative 1 comma infinity.
Excellent. So this is negative infinity comma negative 1 union negative 1 comma positive infinity. And what is the range?
Negative infinity
Mm-hmm.
comma 1, or negative 1, union negative 1 comma infinity. When it still say the same, or it change?
So do you know do you have the value of x for which the y is 0? Y is neighbor 0, right?
Yeah.
Right? Y is neighbor 0. So the range is negative infinity comma 0 union what? 0 comma positive infinity. Make sense? Y can be negative 1 because if you plug in x equal to negative 3, right? So y can be negative 1 if you see the fx equal to 2 over, what is that, x plus 1, is that right? So if I plug in x equal to negative 3, so what is f of negative 3? 2 over negative 3 plus 1 is 2 over negative 3 plus 1 is negative 2. It's negative 1. But there is no values of x for which the y is 0. So that's why you have to exclude 0 from the range. And what happened here, guys, is what happened here? Does the function increase or decrease here? Decrease. And what happened here? Decrease. So the function decreases. The function decreases on the interval negative infinity comma negative 1 and negative 1 comma positive infinity. Okay? And now the next one is, excuse me, fx equal to 1 over x squared. So fx equal to 1 over x squared. So if you want to graph this function, guys, so look at the x value and the y value. So this function is also undefined. For what values of x, this function is undefined. What happens if I plug in x equal to 0? Undefined, is that right? So if I plug in x equal to 0, this is what? Undefined. So if I plug in x equal to -1, what will happen? 1. If I plug in x equal to, let's say, -10, what happened?
1 over 100, or 1 over, -1 over 100.
No, when you plug in, this is square function. Sorry, this is x equal to 1 over x squared, right? So when you plug in -10 and square here, that will give you a positive number. Is that right?
Oh, yes, sir.
So you said, which is 0.01. Is that right? And then you see if I plug in here -100, oh my God, it's blow up, right? It's a pretty big number. Pretty small number, I'm sorry. So, does that make sense? So now if I plug in, let's say x equal to 1, positive 1, so this will be 1. If I plug in x equal to positive 10, it will be 0.01. Are you guys with me? But, hey, what will happen if I plug in, let's say, -1 over 10? If I plug in x equal to -1 over 10, right, what will be the y value? What will be the y value if I plug in -1 over 10? It will be 100. Explode. Right? So now, if I plug in, hey, even like a -1 over 100, what will be this? This will be 10,000. Is that right? So what did you observe here as the value? Now look here. This -1 over 10 is -0.1. This -1 over 100 is -0.01. Yes, right? So as the value of x approaches to 0 from the left, right? So your y value blow up. Your y value explode. Your y value increases without bound. As the x value approaches to 0, your y value increases without bound. Same thing happened here, guys. So if I plug in 1 over 10, and you know the 1 over 10 is 0.1, is that right? So what will be here? It will be 100. And if I plug in, let's say, 1 over 100, right? So this is 0.01. So it will be what? It will be 10,000. Now, what you need to know is, hey, as the value of x gets larger, as the absolute value of x, you know, like, so how to say that? As the value of x increases, as the absolute value of x increases without bound, increases, you know what I mean? The value of x, as the absolute value of x increases without bound, the value of fx approaches to 0, right? I can write down like this, okay? As the absolute value of x approaches to infinity, that means increases without bound, right? Right? As the absolute value of x approaches to infinity, you can say that increases without bound, as your y value, or you can say your fx, gets closer to 0. Or you can write down fx approaches to what? 0. Right? That makes sense? So, right? And then as the absolute value of x approaches to 0, then what happens? Your fx, or you can say y, whatever, it's the same thing, increases without bound. Or that means your f(x) approaches to positive infinity. Are you with me? So now if I want to draw the graph for this function, okay, so what type of graph I will get? Look here, guys. So I'll get like a, so this is my x-axis, this is my y-axis. So you remember, as the absolute value of x approaches to infinity, your f(x) gets closer to 0. So that means infinity, the absolute value of x approaches, so it will be closer to 0. You know what I mean here? And it will be closer to 0 here. So it goes like, you'll have a graph like this. As the absolute value of x approaches to infinity, so that means as x approaches to negative infinity, or that means x, absolute value of x increases without bound. If it approaches to negative infinity, your y value closer to 0. Approach to positive infinity, your y value closer to 0. But when the value of x approaches to 0, right, as the absolute value of x, because x can approach to 0 in both directions, right, from the negative, from the left and from the right, it can approach like this. So that's why we are taking absolute value of x. As the absolute value of x approaches to 0, your y value blow up. Your y value increases without bound. So that means your y value approaches to infinity. That makes sense? So you have this kind of graph. Hey, did I make sense here? Okay. So now you see that. So what is the domain of this function? What is the domain?
Negative infinity, 0.
Yes. Negative infinity, 0, union 0, positive infinity. So this is the domain. And what is the range?
0, negative infinity.
Yes. Do you include 0 or not?
But you would not include it.
Yeah, we do not include 0, right? Are you with me? Because there is no such x value for which the f(x) is 0. That makes sense? So the range is 0, positive infinity. That makes sense? And what I have in here, the function, what is the vertical asymptote? VA. Vertical asymptote. VA means vertical asymptote here, okay? And this graph, look here guys, this graph never intersect what? Y-axis. You know what I mean? It's pretty close, but never intersect y-axis. So y-axis, which is x equal to 0, is the vertical asymptote. So x equal to 0 is the vertical asymptote. And what about horizontal asymptote? What is the horizontal asymptote? Yeah, y equal to 0, because x-axis, you see that? Y equal to 0. And you see that the function, what I have in here, does the function increase or decrease? Increase. So function is increases on negative infinity, 0, and what I have in here? Decreases on 0, positive infinity. So these are the open intervals of the domain, right? These are the open intervals of the domain where the function is increasing and decreasing. That makes sense? Oh, sorry. You got it, right? Okay. Yeah. Now it's pretty much, look here guys, it's the same thing, like so graph gx equal to 1 over x plus 2 square minus 1. So you graph gx equal to 1 over x plus 2 square minus 1. Okay. So now, look here guys, so your original, your parent function is fx equal to 1 over x square, okay? Right? And this function shifted 2 units to the left. You know that, right? If you have y equal to f of x, right? F of x plus a is the what? Horizontal shift of the graph of y equal to fx, h units to the left if h is positive, right? And h unit to the right if h is negative. You guys know that, right? So now you shift horizontal shift of 2 units to the left. Horizontal shift of 2 units to the left. So that will give you, if you consider this, let's say gx, okay, it's hx, whatever, it doesn't matter. So that will give you 1 over what, x plus 2 square. Right? And then vertical shift of 1 unit down, vertical shift of 1 unit down. Vertical shift of 1 unit down. If you shift this vertically down, then you will get gx equal to 1 over x plus 2 square minus 1. That makes sense, guys? So you see the graph looks like this. You look at the slides, okay? If you look at the slides, you can see that. So the graph is, like let's look like this. Okay? So the graph of y equal to 1 over x square shifted 2 units to the left and 1 unit to the down. So the graph is, I think like you'll have a, so this is your x-axis, this is your y-axis, you shifted 2 units to the 1 unit down. So 1 unit down means this is the line x equal to 1 and 1 unit down, right? So x equal to negative 1. So this is the line x equal to negative 1, right? And you shifted 2 units to the left. So this will be the line x equal to negative 2. And then you will have a graph like this. So this is the line, this is the line. Let me not draw the line. This is the line x equal to negative 2. And this is the line x equal to negative 1. See that? So this is the graph of the function. So this is the graph of the function, what is that? Gx equal to. So this is the graph of gx equal to 1 over x plus 2 square minus 1. And now, hey, did you see that? So what is the original asymptote here? What is the original asymptote? You see the graph never intersects the line what? X equal to negative. This is not x equal to negative 1. This is y equal to negative 1. Sorry. This is y equal to negative 1, right? Right? So now you see the original asymptote is y equal to what? Negative 1. And what is the vertical asymptote? So what is the vertical asymptote? And look at the graph. This graph never intersects the vertical line x equal to negative 2. Is that right? Right? So this x equal to negative 2. So the vertical asymptote is x equal to negative 2. See that? And then if you look here, the function increases from negative infinity to what? Negative 2. Is that right? And decreases from negative 2 to positive infinity. And what is the domain?
Negative 1, negative, negative 1, negative infinity, and then negative 1, infinity.
So the domain is, you see the domain is,
Oh, the domain.
yeah, the domain is negative infinity all the way up to what? Negative. This is negative 2. You guys know that, right? So domain is negative infinity, comma negative 2, union negative 2, comma positive infinity. And what is the range?
That's negative 1, negative infinity.
Yes, negative 1, comma positive infinity. Negative in, comma positive infinity. Okay. So I think you can do that one, you know. Yeah. Okay, so now let's talk about the asymptotes. Okay, so look here. If you want to find the asymptotes, okay, so if you set the denominator equal to 0, if you want to find the vertical asymptotes, if you want to find the vertical asymptote, you set the denominator equal to 0. Now here, so what is the denominator here? X plus 2 square, right? Right? If you set denominator equal to 0, so now it will be x plus 2 square equal to 0. So, and then solve for x. So that will give you the what? Vertical asymptote. Okay? So you see this is same as x plus 2 equal to 0, and that will give you x equal to what? Negative 2. So this is the vertical asymptote. Are you with me? Right? So this is the vertical asymptote. So how do you, like you see if you have a function f(x) equal to 1 over x, what will be the vertical asymptote? You just set the denominator equal to 0. So this x equal to 0. So this is the what? Vertical asymptote. Okay? Did you get it? And then if you want to find the horizontal asymptote, if the numerator has lesser degree than the what? Denominator. If the numerator has a lesser degree than the denominator, then y equal to 0 will be the what? Horizontal asymptote. Okay guys, did you get it? So now let me show you the example, okay? Look here. So now look at this function, okay? f(x) equal to so you have a function f(x) equal to x plus 1 over 2x minus 1 times x plus 3. So we have this. So now what you need to find here is vertical asymptote. So vertical asymptote, okay? So how do you find that? You set the denominator equal to 0. Okay, so you set denominator. What is the denominator? 2x minus 1 times x plus 3 equal to 0. Right? And then you use the zero factor property. So this is same as 2x minus 1 equal to 0 or x plus 3 equal to 0. So what is the value of x from here? This is 2x equal to 1, and that will give you x equal to what? 1 over 2. And then x plus 3 equal to 0, x equal to negative 3. So now you see x equal to 1 over 2 and x equal to negative 3 are the vertical asymptotes. Are the vertical asymptotes. Did you guys get it? Does that make sense? And then if you want to find the horizontal asymptote, to find the horizontal asymptote. So what you need to do is, hey, we need to find the degree of the numerator and degree of the denominator. Okay, so now what is the numerator? Your numerator is what? What is the numerator of this function? Yeah, numerator is x plus 1. What is the degree of numerator? What is the degree of x plus 1? What is the degree of this polynomial x plus 1? Just 1, right? You know the degree, right? So the degree of the numerator is, the degree is 1, right? So degree is 1. So look at the denominator. So what is the denominator? 2x minus 1 times x plus 3. Is that right? Right? Are you with me, guys? Does that make sense? You use FOIL, okay? So this is 2x squared. 2x times x is 2x squared. Plus 2x times 3 is 6x. Negative 1 times x is negative x. Negative 1 times positive 3 is negative 3, right? So now you got 2x squared. What is 6x minus x? Plus 5x minus 3. Now, what is the degree of the denominator? 2. Because this is the quadratic function, is that right? You guys know that degree means, right? Look here, this is 1 because it has the... Look at every term and the term with the highest exponent, right? So that will give you the degree, the highest exponent. You know what I mean? Like look at the term here. This. How many terms here? 3. And what is the exponent of x? 2. What is the exponent of x? 1. And here, this constant term, it has also x to the power 0, 0. So which one is the highest? So that is the degree. That makes sense? Right? So now, if, so the degree is, you got it, right? So degree of the denominator, degree, so degree is 2. Now, if numerator is less, if the degree of the numerator is less than the what? Degree of the denominator. Are you with me? If degree of numerator is less than the degree of the what? Denominator. Right? In that case, y equal to 0. X-axis will be the what? Horizontal asymptote. That makes sense? So now, are you guys with me? Here, what is the degree of the numerator? 1. What is the degree of the denominator? 2. 1 is less than 2, right? In that case, look here. If the numerator has lesser degree than the denominator, then there is a horizontal asymptote y equal to 0, which is x-axis. So now, what is the horizontal asymptote? X-axis. horizontal asymptote is y equal to 0. Does that make sense? Okay. But you know, if the degree of numerator is same as the what? Degree of denominator. If the degree of numerator and degree of denominator are same, then y equal to leading coefficient of the numerator over leading coefficient of the denominator will be the horizontal asymptote. Okay, guys. So now, for example, let's say your function f(x) equal to 2x cubed plus 3x squared plus 5x minus 4 over 5x cubed plus 9x plus 6, something like that, okay? Look here. What is the degree of the numerator? What is the degree of the numerator?
3.
What is the degree of the denominator?
3.
3. So you see the numerator and denominator are of the same degree, is that right? In that case, y equal to leading coefficient of the numerator. What is the leading coefficient of the numerator? 2 over, what is the leading coefficient of the denominator? 5. Yeah. Y equal to leading coefficient of the numerator over leading coefficient of the denominator. This is the what? This is the horizontal asymptote. That makes sense, guys? Now, if degree of numerator is exactly 1 more than the what? Degree of the denominator. In that case, we will have an oblique asymptote. Look here. If the numerator is of degree exactly 1 more than the denominator, then we will have an oblique asymptote. So in that case, we will divide the numerator by the denominator and y equal to quotient. We disregard the remainder, and y equal to quotient will be the what? Oblique asymptote. Look here. So let's say we have a function f(x) equal to x squared plus 1 over x minus 2. In this case, what is the degree of the numerator? What is the degree here? 2. Numerator has the degree 2, is that right? Numerator has the degree 2, and the denominator has the degree what? What is the degree of the denominator? 1. So the degree of the numerator is exactly 1 more than what? Degree of the denominator, right? So in that case, we have oblique asymptote. So now we have to divide this by this. Okay? So now use the synthetic. You guys know the synthetic, right? So coefficient of x squared is 1 and x term is missing here, right? I'm going to divide this by this. Your x term is missing, so you write down the coefficient of x 0 and this 1, and you guys know that. You bring it down, is that right? So negative, are you with me? So negative 2 times 1 is negative 2, 0 plus negative 2 is negative 2, right? And negative 2 times negative 2 is what? Positive 4. What is 1 plus 4? 5. What is this? This is the remainder. You disregard the remainder. And y equal to the quotient. What is the quotient here?
X minus.
Yes, the quotient, qx, quotient, okay? Qx is x minus 2, is that right? This y equal to x minus 2 is an oblique asymptote. This is an oblique asymptote. Okay, I want to stop here, guys. I'll see you on Thursday, okay? Did you get it? Okay.
Do you have a sign-in sheet?
Yes, I do.